Hi everyone. All right, we're going to do notes 4, key features of graphs. So it's a lot of definitions in here. So domain and range we talked about. Those are your x values and y values. Some of these are going to be refreshers, reviews. So like y-intercept, that's where the function crosses your y-axis. You know that. That's something that you've seen since Algebra 1. Zeros and solutions, again, where the function crosses the x-axis, we call them solutions and zeros. If your graph is symmetrical, if your function is symmetrical, it can be even, odd, or neither. So if it's even, it's symmetric about the y-axis, okay, and we'll talk about all that stuff. And then odd is symmetric about the origin. Okay, again, just definitions so we can talk about those later. So for continuity, if you have a continuous graph, that means it has continuity. There's no breaks, no holes, no asymptotes, anything like that. If you have infinite discontinuity, so if you have a function that increases, I use arrows for increases or decreases at a value, let's say x equals a, from left to right. So that's really this first picture here, okay? If you have basically a rational function, you have an asymptote. That's what that's talking about. Jump discontinuity, where a function at x approaches a value, let's say c, a value c, and has two values. So that's this picture that I'm writing on, okay? Jump discontinuity, you see a lot with piecewise functions. Removable discontinuity, if you have a function continuous everywhere except at x equals whatever that value is of c. So that's your removable, that's down here. It means you have a hole. So it jumps over that value completely and continues. So that means you have a hole. And we'll talk about that this year as well. So your end behavior is what your x values. It just say what the ends are doing. So the x values for your end behavior is what the ends are doing. You're describing which direction that they're going, whether they're going negative infinity, positive infinity. Again, all of these are going to use x values. So increasing and decreasing, you're looking from left to right, okay? And you're describing where your values are increasing and describing where your values are decreasing, okay? Constant, again, you're looking left to right. Where is your graph essentially flat from left to right, okay? Relative max, so a local max or relative max, you can have multiple of these, so it's the maximum, but you can have multiple maximums. Greatest point or points on an interval. Okay, same with relative min, it's the lowest point or points on an interval. And then absolute max and absolute min, that's the one, you'll have just one great point, and absolute min, you'll have one low point, and that's the lowest one or the greatest one, okay? The greatest and the least. Okay, so that's that terminology. So for even and odd functions, we have a few of these practice problems. So we said for even, they were symmetric about the y-axis. So basically, if you look at number 1, this one is even because if you flipped or reflected over that y-axis, you would get the same function. So y equals x squared gives us an even, it's an even function because of that symmetry. It divides it completely in half. Also, because this exponent right here is a 2, so an even function will have all even degrees, okay? It can't be mixing and matching, it has to be all even. So you can use either to help you. So then number 2 for absolute value is even because it's symmetric if you reflect it across the y-axis, okay? So number 3 is not even, okay? It is not even because if you expand and FOIL, you get x squared minus 2x plus 1. This little x in the middle has a power of 1. This constant has a power of 0, which is even, but this 1 right here makes the function not even anymore. It's not symmetric about the y-axis, so you can't say that it's even anymore. And then for number 4, if you see something like that, the constant will always have an exponent of x to the 0 or whatever variable to the 0, because if you remember, anything to the 0 is also 1. So this one is even because all of these exponents right here are even. Okay, so that's why. And so we already talked about why 3 wasn't even, because you've got that 2x to the first, which makes it not even anymore. They all have to be even exponents for it to work. So then for number 5, okay, number 5 leads us to odd functions. So if you're looking, f or 4x to the 7th plus 5x3, and you can change this to x to the negative 1, okay? So when you change it so you can tell if it's even or odd, if you check in your calculator and you plug this into your graph, which I'm doing at the moment, so I can show this to you. X negative 1. It'll show this picture, right? And essentially it looks like this, something like that. It's a lot prettier on the actual graph itself. There we go. This would be considered an odd function because if you look at the origin, it's symmetric about the origin, which means if you rotate this graph 180 degrees, you would get the same graph out of it. So I'll show you this better when we're in class. You can do it on paper. But if you look at y equals x cubed, 1, all of the exponents in the function have a odd degree, but also if you rotated this 180 degrees, doesn't matter which way, it will give you that odd function, okay? Same with y equals x, this is an x to the first, and again, if you rotate it, it does give you that odd function. So you have to have all the odd degrees in your function, or you can rotate it to check it out, okay? So just real quick, even, odd, or neither. So you have these 3 I want to take a look at. I want you to determine if these 3 are even, odd, or neither. So go ahead and do that now. All right, so these are the answers I got. Neither, neither, and even. So none of these were odd, okay? The reason that 1 and 2 are neither is because you have a mixture of even and odd. If you expanded and FOILed this group out, you would have a mixture of even and odd numbers. And then For number 3, remember x to the 0 is an even number, so you would get an even function there. So we're going to stop the video there. We'll do key features either in class or in another video. All right, have a great day.